All right, so let's get started. So now in the last lecture or sometime back, we wrote code for insertion sort. So this is the code for insertion sort. So now we want to reorganize this code. We want to reorganize this code so that the ideas that you learn by reorganizing this code, you can apply them when you are trying to solve, when you are trying to work on big projects. So right now, if you see this, the size of this code, the number of lines in this code is around 138 lines. It's within a small period of time, you may end up writing 1,000 lines code, 2,000 lines code, 3,000 lines code. So when you write 2,000 lines, 3,000 lines code, then having the whole code base in one file is not a good idea. Well, even 3,000 lines, 10,000 lines code is also okay, but when you go in work on real software, if you want to write a bash terminal, or if you want to write Linux kernel, or if you want to develop a web browser, or if you want to build a video player or audio player, the number of lines of code will be 50,000, 1 lakh, million lines of code. Of course, not all the lines you will be all the code, not one person. There will be huge teams with hundreds of members working on the same thing. Then the way you are writing programs so far, it's not going to work the way you are going to. So we have to learn new ideas, new tricks, new techniques, new approaches. So that's the plan for today's course. So now let's say, so now we want to re-architect, refactor. The term software engineering people use is, we want to refactor our insertion sort code, which supports insert, delete, search operations. So let's let's make it as a dictionary, linked LL dictionary, MKD linked list dictionary. So and then we are copying cp ... insertion.c to a different file called as main.c. Close folder. Where is my Okay, you are all able to see the program, right? The screen. Okay. So now what we are going to do is we will create a new file, and all these this node, the whole code associated with the linked list, we want to keep it let's say Sai Kiran is working on it. Okay. And so we put the whole thing in let's say helper.c file. Okay, helper.c file. So now you can see main.c now only contains the main function, and helper.c contains the code for linked lists. Okay, and you can see that there are errors here. Wherever node is there, there is a that red underline mark is there indicating it's not defined. So what we should do is we have to define the data type node, and we include it put in a header file called as node.h. And in node.h, we have the definition for the type. We are defining the type node. All right. So what all the include files we should have in this helper.c, stdio.h, hash include stdlib.h, hash include node.h. So .h is the extension header file. So now when we include node.h, then the compiler, this code, this definition is textually included in helper.c, and you can already see that the editor itself recognized that node is a user-defined data type. Are you all with me? So usually what happens is, before I clarify the question asked by Sardak. So now if I comment node.h, then you see that there is an error that is being shown because the definition for the type node is not there. And if I uncomment it, you can see that the text for node.h, the text that is present in node.h is included, and the error goes away. Well, the difference between node.h and is control screen. Let's see. Usually what happens is all the include files are present in some standard directory, like for example in /user include stdio.h, user include. So this is the file. If you see ls, all the include files are present here. So the compiler will look for include files in that standard directory, but if you put these double quotes, it will look for that header file in the local directory. Does it make sense? When you put double quote, then the compiler looks for that in the local directory. And if you look at the functions within this helper.c, if someone, it's not a string literal, no. If you are, so what are all the functions present in linked list program in this helper.c? One is allocate node on line 9, and other is free node in line 20, and then insert node on line number 26, and then delete node, and then search node, print list. So these are the functions present. Okay, does it make sense? Among all these functions, can you make a logical distinction between these functions, with the functions that you are seeing? Do you make some kind of logical distinction? What is the logical distinction you see, Apar? Logical distinction means logical distinction. In terms of their functionality, see, the way I see it is insert node, you want the outside world to see, right? Insert node, delete node, search node, print list. These functions, you want the outside world to see, because if someone wants to insert something into the dictionary, they want to use the insert node. If someone wants to delete something, yeah, some kind of abstraction, then they will use delete node. It's not like that. It's like the API. Like, for example, you call printf, you call scanf, you call different functions. Printf internally may use different functions to do printf. Scanf internally may use some other functions to do scanf. Similarly, in this program, the way you have written some kind of linked list library, you insert node, delete node, search key. These are the things that you would like to expose it to the outside world. But allocate node and free node, they are your internal constructs that you are using to solve the other problems. Yes or no? So in terms of the visibility, so we want some things to be visible and we don't want some things to be visible. Some things we want them to be visible and some things we don't want them to be visible. So free node, we want it not to be visible to the outside world, but insert node, we want the outside world to be, it should be visible to the outside world. Okay. So now, yeah, so here, let's say print list. This is the code that we have. Let's now what we did is, okay. So now our code is divided into three files. One is main.c. And do you see how the main has become so simple? The main.c is so simple now. And helper.c is like, for example, you can write a terminal interface in main. And helper.c is the place where the linked list code is present. And node.h contains the data type. Okay, so that is how we have structured our whole program. Now let's compile this program and see what happens. Okay. Yeah, it's a good question. Muskan has a good question. We will see how it works. So we are, so now we are compiling GCC main.c and helper.c. And you see there are two warnings, but an a.out has been created. And then we need, of course, a cp.keys.text to this. And then when we say .a.out, keys.text, it is working. So when we compile, the compilation is still going, okay? But what, but the compiler is complaining that it doesn't know the data type of this function insert node and print list that we are calling in this main. And it is saying that I don't know the function prototype. Function prototype means what is the return type of insert node and what are the parameters being passed to insert node and there. And what are the parameters being passed to insert node and what are the type. That information I don't have. But so it is complaining, okay? It is giving the warning. If you see, it is giving the warning. And then the same complaint it is giving for print list also. The way compiler is handling this stuff is, if you see the actual compilation process, what happens is, when you give this command, this is the command that you are giving. So what internally compiler does is, it takes main.c and it generates a file called as main.o. It generates an object file main.o. So when it generates this main.o, it doesn't know anything about insert node, or it doesn't anything about print list. All right. So yeah, but then when it is generating this, it complains, no, insert node and print list you are using, but you didn't give any information about these two functions. I don't even know what type of parameters they are supposed to expect and what they are written. So it gives a warning, but still let this compilation process goes through. And then what happens is, it takes helper.c and generates helper.o. Same. So now the executable is not yet ready. So now there is a linker program, so which takes main.o, helper.o, and standard libraries. Okay, libraries. All these things it takes, and it generates a.out, which is ready for execution. So when main.o is generated, what happens is, when there is a call to in means, think of it as insert node, the compiler doesn't know anything about where insert node is, the code for insert node. But when the linker figures out that insert node is defined in helper.o, and it patches up this thing with the address of the insert node function from helper.o. Not only insert node, you also call printf, right? So printf also, the code for printf is not available, but since you include, but at the time of linking, what happens is, you link it with the standard library, and wherever printf is being called, it will be, that call will be linked to the code that is present in the standard library function. So this is the process that happens underneath. And but then, so there is a what do I say? There is a there is a warning which says, I don't know anything about the insert node and print list. So what we can do to avoid those, we can tell compiler that print list. We can tell compiler that print list is a function. It doesn't take any parameter, void, and it returns nothing. So now this is how it is. Now when we compile, what happens is that warning goes away. You can see the print list warning, that the implicit declaration of function print list, that warning goes away, because the compiler now knows that the type of the print list is this, from this signature. Are you all with me here so far? Doing all right? So how it helps this, how this prototype help is, if I put print list 12 here, then what happens is, since we have declared its prototype, compiler will figure out that there is an error. Hey, you said print list doesn't take any parameter, but you are passing a parameter here. So there is a problem. So compiler use the queue that you have given to generate errors for you. Okay. So now when we compile, now it says too many arguments to function print list. The type of the print list, is, you said it doesn't take parameters, but you are calling print list with a parameter. On the flip side, if we make this one, if I comment this out, then the compiler doesn't have information about that print list wouldn't take any parameter, and no, so that becomes an issue. Yeah, so in this particular case, it is kind of not, it's okay, because the 12, no, whatever parameter, we are, for some reason, no, that the parameter 12 just got ignored. But there are some cases where what happens is your program can crash because of some reasons which are a little bit complex to explain here. But you're not supposed to call print list with 12 as parameter, but you're calling print list with some parameter. Does it make any sense to you? What has int? The actual definition of print list, it doesn't have any parameter. Oh, here we have print list first. Oh, really? Oh, then earlier. Oh, okay. It's interesting. We gave print list key. Okay, let's do this now. So void. Then the whole story I told, it's still true, but we are misguiding the compiler. So this is the thing that we are supposed to give. Okay, now I changed it in helper.c to void. Does it okay? Is it okay now? And then let's say now, let's see what will happen if I incorrectly declare the type and compile. No, we changed, Akshat. For just follow my line of thinking, and then we will say I just changed this print list. The parameter key is replaced with void. Okay, let's see what will happen if we get any. Yeah, it will still work. Okay, that's what I thought. But what we are doing is, no, so we are kind of giving an incorrect code to compiler and making compiler do things which it's not supposed to do. Okay. Just follow what I'm doing, guys, and then we will, know, each of, I'll take the questions. The point I want to make here is, what is the point I want to make? That we have to give a function signature. We have to give a function signature. So we have to give a, So we have to give a function signature or prototype so that the compiler will, so that we guide the compiler about, I am calling print list, okay, and this is its prototype, and the linker will figure out where that print list is, and then it will do the appropriate linking. And insert node, we didn't do it yet, so the compiler is throwing a warning there. How can we fix the warning thrown by the compiler here? How can we fix it? Yeah, void insert node int. Remember, we don't need to give the name of the parameters. We just have to tell the type of the parameters. Now, when you compile, the errors are completely gone. The warnings are completely gone. Are you all with me here? The Aneka's question, could this be void? Could this be void? It cannot be void because on line number 16, we are calling insert node with a key. So it cannot be void, it has to be int. Okay. Node.h just contains the definition of the structure, that's all. All good. So now, based on what you have seen, what is the scope of these functions, print list, search node, delete node, all these things? What is the scope of these functions? Scope. No, they are, you can call these functions even from main.c. That means the scope of all these functions is across multiple files, all the files. They will be able to see these, all the files, the scope of all these things, it is okay. Are you with me here? The scope of these functions? Yes, no? So, but then, you know, this allocate node, free node, these are functions which you don't want them to be visible outside. You don't want allocate node, free node to be visible outside. So, like, for example, the user innocuously or, you know, plays a mischief and says allocate node 10, you know, then what will happen? He's not supposed to use the allocate node. Okay, but the compilation will still go through. It will just give a warning, but you are exposing allocate node in your helper.c to main.c. Okay. It does, we don't want allocate node to be visible to main.c. Are you all with me? We don't want allocate node to be visible to main.c. This is an important thing because right now, you know, no, it should be, yeah, that's where I'm coming to, because later on, let's say, you know, Anusha will think linker list is boring and I want to have a tree dot, I want to use instead of linker list, I want to use a tree data structure. And while doing the tree data structure, she uses the same allocate node function, but perhaps she uses something like tree node. Okay, something like that. So all these things can happen. Now there is a name clash. You know, when we say allocate node, does the allocate node means the allocate node of helper.c or of the linker list, or allocate node of tree.c? So you get what is called as a namespace conflict. Okay, you get the namespace conflict. So in order to kind of localize, you don't want allocate node to be visible outside. So what we do is we just say static. When we put the static keyword, then when we try to compile, then what happens is the compilation doesn't go through. When we put static, the scope of allocate node will be restricted to helper.c, but we are using main.c allocate node function. And when the linker tries to find out where allocate node is present, it will not be able to find, and it throws an error. You can see this undefined reference to allocate node. This is a linker error. What you are seeing here, it's a linker error. Even if you provide signature, no, just because you provide signature doesn't mean, no. Anusha wants to show her, allow you to use your allocate node function because we made it static. You can add it. You can add, whatever the signature in main.c, but it's not going to work. Are you all with me, everyone, so far? Focus on first what I am saying, hold your questions and then I'll answer them, okay? The baseline for today's class first needs to be established. Till this point, are you with me? Now comes couple of, there is one small thing with respect to, it's not necessary, I guess, Abhinav. So yeah, don't save. It's not necessary. The order of compilation of files, it should not matter. Have to check the ones. We don't need to compile it because at least in this one you can see that we can compile no main.c first. We have it, it's not, it doesn't matter. Are you using GCC or which compiler you are using? Okay, I don't know what's happening at your end. I'll fix it later. Print list. Okay. So now let's say for some reason, which is it's not a let's say in this in this code we have a variable called as version, which holds so you want to check when before using this, before using this linked list library, you want to print here printf using just use percentage. I want to use LL underscore version. You can see as it is now that this LL underscore version is not, this variable is not recognized, and it is saying no, this variable is undefined, and it is there in header helper.c. Does it mean the scope of the variable LL underscore version is restricted to only this file? Are you with me? Does it mean the scope of the variable helper.ll underscore version is restricted to this file? Well, it's not really the case. For some reason, I think there are some good reasons for it. The scope is, it doesn't compile. It can, yeah, it's not. So when we are using this a variable from other file, we have to explicitly declare its type, because it is very important for compiler to know its type and all. And we have to tell the compiler that this variable LL underscore version, it is defined elsewhere. And the way we are going to do it is by making this extra. So now when you compile this program, you will get it using linked list library version 1.1. And do you see? If you want to use a variable that is declared in other file, you have to declare it by using extern. Extern is a keyword. Are you all with me? Are you all with me here? Yes, no. And if I make this one static, okay, now when I compile, let's see what happens. It says LL underscore version is not available, because when we put static before this definition, then that means we are restricting this to only this file. In fact, it is very important to keep, to make this variable head also a local variable to confine its scope only to this file, because head is a very common keyword which will be used, not very common variable name, which could be used in different places. And then this we get what is called as this namespace conflict, and lots of weird things will happen. So you should put on line number 8 also the static keyword so that head is not visible outside this one. But on line number 6, we want this to be visible outside. So we make this just like this. So the scope of LL underscore version variable is across all files. The scope of the head variable is confined to this file. Are you all with me here? Makes sense? Yes, no? All good? Nice. What else the story? So now one thing we would like to do is in node.h, okay, we can have, other things, all these. So this function, all these things void, they can all go to, so void delete node int and what is search node, delete node. Yeah, search node, no, search node requires node star search node. Insert, delete, search. All these things we can keep. And what we do here is we hash include node.h. Okay. Does it make sense what we did now on line number 4? All the prototypes, whomever is writing this linked list code, like for example, they can even rename this one with ll.c. ll stands for linked list.c, and this they can rename this with ll.h, and then here we can have ll.h, and here at the beginning we will have ll.h. So whomever, if someone wants to, if you want to build a software and ship it to someone, you decide, you write this ll.c and you write this ll.h and you give it to them, and they can use your ll.c and ll.h to write your programs, to use your linked list library. In fact, you don't need to give ll.c because ll.c is your intellectual property, right? You don't want to tell the other person how you wrote this brilliant high performing linked list program. So what you do is you only give ll.o. You take ll.c and you generate ll.o and you give this ll.o to that person. And along with that, you also give ll.h. So the way you ship ll.o and you ship ll.h, and there you go, and the other person will be able to use your software, and you are not giving him away your source code. The header file only contains the signatures. Ship software. Does it make sense, guys? Are you all with me? Doing all right? Because when I write main.c, I don't need ll.c. I just need ll.o. I'll link my main.c with your ll.o. Yes, yeah. Okay. Now, so there is one question from the other class. Why can't we put ll.c, everything? Why can't we just include in main.c? Why do you want to do all these things? Why can't we include ll.c? What are the challenges in including all these things? Why this hangama? I'll put no include ll.h and then include ll.c. Why can't we do that? Okay, so number one, there are multiple reasons for it. So of course, intellectual property, you don't want to give away your source code, number one. Number two, let's say it's not, you are not concerned about it and it's an internal project, so intellectual property is not an issue. But what happens is, let's say if your program, if your software has if your software, let's say your software has 1 million files, or no, or let's say some 10,000 files. So now what happens, you take, if you include all of them and create one main.c, what is going to happen? One main.c, and then you try to compile it. So what happens is, even let's say you are working on one particular file f2.c, and even if you just modify this one, everything else is good, but you are just modifying this f2.c, then what happens is the whole, or but the way, particular way in which you are doing the compilation, you are including everything. Because of that, you will get one file with 1 lakh lines of code and you compile it again. You make small change to f2.c, and you, in order to generate the software, you end up compiling the whole 1 lakh lines of code. So you have a build time problem. The build time will just explode if you just use, include everything in one file. That's a build time problem. Are you with me? Compilation time, build time. In my terminal, will I write name? There are ways to do it without explicitly writing them upper. Number three is namespace conflict. Like for example, in ll.c you are using linked list. In tree.c you are using, we have code for tree data structure. Now when you include them together, then there can be two allocate node functions within the same file, and the compiler will complain, I am seeing two functions with the same namespace conflict. And that becomes a challenge. Are you all with me here? Good. Intellectual property, increase of build time. We can include even any file you can include, even if it's a .c file also you can include. But .h is a kind of thing for in your head that it's an include file. Okay. So now you want to compile this code. Okay, you want to, so this is, now we look at what is called as a makefile. In order to, I have some predetermined makefile. So you see the makefile here, follow me carefully. In this makefile, we are, so we are on line number 6, we are saying here we are using a GCC compiler. On line number 7, we are using that, what are the options that we want to use to compile. And then on line number 12, we want to generate our program LL. Let's call the executable that we would like to generate is that name is LL dictionary. So in order to, the makefile doesn't have any extension. It starts with capital M-A-K, makefile. We just call it as makefile. And in order to generate this one, we need main.o and ll.o. Okay, ll.o, this is main.o. Wait, you'll understand. ll.o, Okay. So here, let's first compile and see what happens. Control L. Let's make. Now it compiled. Oh, sorry. LLDict keys.text. Okay. Let me see. Okay. So now let's hear me out. Yeah. So when you do make clean, everything gets removed. So now on line number 12, you are seeing a target. We want to generate, we are giving it in a make file, we give a recipe for preparing some target. In order to prepare LLDict, okay, think of LLDict as, it's an executable you want to generate. In order to generate LLDict, you want two object files. One is main.o and other is ll.o. And once you have these two object files, the way you use them to generate LLDict is given on line number 13. Are you with me here? In order to generate LLDict, that is the target that you want to generate. You want to generate an executable, LLDict. In order to generate that, you need two ingredients. One is main.o and ll.o. You are specifying the recipe. Okay, you are on the line number 12, you specify the targets, you specify on line number 13, you specify the recipe to compose the targets. Are you with me so far? Like in order to know our sambar example, no, if you want to make sambar is too difficult, okay, to make. If you want to make coffee, you need milk and you need sugar, you need coffee powder. Okay. And how do you make coffee? So these are the ingredients, and the next line contains how you use the ingredients to make coffee. Mix up milk. $CC is replaces whatever on line number, wherever CC is defined as GCC. So $CC means it replaces it with GCC. Okay, mix up milk plus sugar plus coffee. That is the actual action. Action is given on the next line. On line number 24, ingredients. On line number 25, the action. Yeah, that's true. Dollar means gives the value of the variable. So the advantage of using this one is later on, if you decide to use instead of GCC a different compiler clang, then you just change it at every place, it changes automatically. Okay. All good so far? Same C flag is also same extension. You replace wherever C flags are there, you compile this gets translated. This line gets translated to GCC minus pedantic minus vol minus G minus O LLDict, so on and so forth. That is how it gets. How to open a pedantic means it clearly explains the error that is being, the warning, whatever error, it gives an elaborate answer. Like for example, okay, we'll see later. Pedantic means you read man page, it just means it when you give an error or warning, give a very elaborate message to the user. Pedantic means no teaching, pedant. Now, what does main.o depend on? Main.o is dependent on main.c and it is dependent on ll.h. And what is the recipe used to create a main.o? It is given on line 16. And if you look at LL.o is dependent on LL.h and it is dependent on LL.c. And the recipe that we use is or it is given on 19. Are you all with me here? This is a recursive recipe specification, okay? So now what happens is, pay attention to me. If main.c changes, what makes the object file is -c. -c option here generates object files. So main.c, if main.c changes, then what will happen? Will main.o change? Yes or no? If main.c changes, main.o change. If main.o changes, then LL dictionary will change. So what happens is when main.c changes, then when you do a make of this executable, then only main.o will be generated, and then so only line L16 and L13 becomes active when main.c changes. LL.o will not be compiled. Think of the case where there are 1 million, or no, 1 million is too large. Let's say 1000 dot object files feeding into LLDict. So now if you change this one, out of this 1000 object files, only one object file will be recreated. The other will be kept as they are. Are you with me here? If there are 1000 other or 999 other object files, you save the compilation time for all of them, right? Yeah, only 12 and 5 will change. So only the corresponding executables will be the line number 13, line number 16 will be modified, and then line number 13 will be modified. So now, for example, let's go here to our where is this? This is main.c, and here we didn't right now. When we do this execution, we don't have new line character here. So let's say we go and introduce this new line character here. Okay, we use this new line character. So now, since we changed main.c, if main.c changed, do we need to compile LL.o again? Do we need to compile LL.o again? No, right? And that's what make automatically does for us. When you do make conflicting types for search node, there is some issue here. Read. I see what is happening. Oh, because LL.c included. Sorry. Okay. Now, earlier I have included LL.c here on line number 5, and that is causing all the problems. Okay. But in any case, now what do you understand what happened here? Only main.c is compiled. And then this linking is happening. Only these two instructions are invoked. Are you with me here? How many of you understood what's happening here? This one, what happened is since we modified the main.c, using this instruction, we generated main.o. And so this is what happened. This is L16. L16 got invoked. And then we want to, since main.o changed, we have to generate LLDict. And this is what happened here. And using line 13, LLDict has generated. But L19 didn't get generated. Pedantic, it's not a big deal, guys. You need to know what to focus on. Okay, pedantic is just a, the error warning, it just tries to explain it more clearly. Okay, so that's not the point of this whole exercise. If you don't want this, you can just make it empty also. It doesn't matter. So now if you see, when you say, go get some food apart. So if you see make, then LL dict, so the executable is, there are no modifications that are made. So it says, no, the executable file is ready. Do you understand what's going on? How many of you kind of got? And if you see, like for example, now, if we change something in LLC, okay, let's say we change something in LLC. Now, if you compile it now, what happens when we changed it in LLC, what will happen? What all the commands that will be executed since LLC got changed? How does the compiler know? It looks at the, like, for example, now we changed LLC. The timestamp of LLC is greater than LLO, and that is how it knows that the .c file, the source code changed after the target has changed. If you go here, LLO is dependent on LLC. If the timestamp on LLC is greater than LL.O, then what will happen? Then Makefile will know that after the last time it generated LL.O, LL.C file has been modified. So it has to regenerate LL.O again. Make sense? Are you all with me? Kind of, I know you're hungry, but I want to complete this topic in a couple of minutes. And if LL.H changes, what will happen? Let's say we go to LL.H. If LL.H changes, then what will happen? Let's do, see, when we changed LL.H, because if you see here, everything changes, so all of them are component. Makes sense, right? Because main.o depends on LL.H, LL.o depends on LL.H, LL.dict depends on these two. So everything is recompiled. Okay, so that's all. So that is how, by Makefiles are fantastic tools, and you should, for anytime when you start writing a program, you should first write a Makefile for it, for that software. So to summarize, when you are building huge software systems, these Makefiles and complex build systems are important, number one. Number two, in the next class, we will see how to use C preprocessor in a very clever way to, when you are building large systems, preprocessor. We take a deeper dive in the next class. Third is you should use Git or any version control system. So these are basic things you need to learn for when you are building large software. So for this one, I will provide a video link which you can watch. This one today we discussed, and C preprocessor is something we will see in next class. We will see aspects of C preprocessor which will be useful when you are building huge software. Okay. So I'm sorry, that's all. I took a little bit more time, but that's all for today. I see 47 students. It started with 60. So